Okay, Izzy, it's hard to explain these oxidation reduction problems over the phone. So I thought I would just make a short video and forward it to you and let you work through a couple problems. So I was looking at that worksheet that you sent me, that you sent me yesterday, and this is a tough problem right here. And I chose this one to kind of go through piece by piece to see if you can follow along. Now, you're studying oxidation reduction reactions, or so-called redox reactions, where one species, one chemical is going to be oxidized. So that means it's going to lose electrons. That's oxidation. And reduction is going to be gains electrons. You have to be able to understand how to get the oxidation number of each of the elements. Now, there are some that don't change most of the time. Oxygen is mostly a -2 charge, oxidation number. Hydrogen, mostly +1. So it's the other players that we can look at and say, hey, obviously zinc over here is a metal, zinc over here is part of a chemical compound. So, let's look at zinc first. We have zinc here, and this is nitrate. NO3 has a -1 charge on it, polyatomic ion. I've got 2 of them, so zinc is going to the +2 oxidation state, +2 electrons. So there's your half reaction for the oxidation of zinc. Now we have an interesting thing here. We've got nitrate here, NO3, we've got some nitrates here, and then we have an NO2. Well, obviously in the nitrate here, this is going to be 3 times -2 plus 1, so this has to be a 5 for that nitrogen. And over here, we have this nitrogen here is going to be 4, because I have 2 times -2, that's -4, so then my nitrogen is going to be a +4. So what you have is you're going to have N plus an electron to give me nitrogen with +4 oxidation state. So this is the reduction part. So this is the oxidation, reduction. Now, you have to have the same number of electrons in each half reaction. So if I multiply this by 2, I get that. And then I can say, all right, now I can go ahead and think about what's going on with my balancing my chemical equation. So if we do that, you might be saying, well, zinc, I can leave the zinc alone for now. See how that goes. Now this HNO3, well, only 2 of the nitrogens turned into this. So if I put a 2 there, that helps to balance that. But I've got 2 nitrogens, 4 nitrogens. So if I put a 4 here, let's see where we are in terms of everything being balanced. Well, I have 1 zinc, 4 hydrogens. Over here, if I put a 2 in front of my H2O, then I've got 4 hydrogens. I've got 4 times 3 oxygens. So let's see what I have on this side. 4 times 3 is 12 oxygens. So I've got 6 oxygens, 4 oxygens, and 2 oxygens. This is equal to 12 oxygens. So everything is balanced at that point. This was kind of tough because you have nitrate here, you have nitrogen dioxide here, and so you have these nitrogens doing 2 different things. 2 of them aren't changing, and two of them are. So that's one example. Let's go through another one. Excuse me. And the other one I copied down that I thought was pretty interesting in terms of a difficulty standpoint was this particular one. I have some tin, and I'm going to react that with HNO3. You're going to see with oxidation reduction reactions, you're going to see a lot of times metals are reacting with acids. It's very common. And the products that you're going to get, oh, plus water. And you're going to get H2SNO3. I think that's called stannous acid. And you're going to get nitrogen monoxide. So this is kind of similar to the last one. So let's take a look. Tin here, I wrote a little 0 above that because it's just a metal by itself. And over here I've got, well, let's take a look. 3 times minus 2 is minus 6. Plus 2, that's going to be minus 4, so this has to be 4. So I got my tin, and it's turning into tin 4 plus 4 electrons. I go down here and I look at my nitrogen again, and this one isn't quite as confusing because you have the nitrate here, NO3, going to NO. So let's just take a look at the nitrogen in this case. Well, again, this is plus 5, okay, because minus 3 times minus 2 is minus 6, plus 1, minus 5, so that has to be plus 5. Over here, you're going to a plus 2 oxidation state. And so that, let's go ahead and look at our nitrogen. We have nitrogen, and we're going to do a plus 5 plus 3 electrons, and that's going to give me N plus 2. This is my oxidation half reaction. This is my reduction half reaction. I want to get the same number of electrons, so we have a 4 and a 3. We'll multiply by a 3 there and a 4 there, and that's going to give us, and then we can go ahead and look at that. That's going to give us 3 tins, going to 3 tins, 4 plus 12 electrons. Down here I'm going to have 4 nitrogens plus 12 electrons to give 4 N2 plus. And right away you could tell if everything's going to work out because the charges should all work out. The number of electrons should cancel when you add, and you should be in good shape. So once again, oxidation and reduction. So now I'm going to go ahead and use these coefficients to try to balance this. So I'm going to put a 3 in front of my tin, and oh, hang on, I got a phone call. Oh, okay, sorry about that. Anyway, so I took my 3, I put it in front of the tin there. I'm going to put a 3 over here, okay? So I have 3 tins on this side, 3 tins on that side. Now I'm going to, everywhere I see a nitrogen, I'm going to put a 4. Put a 4 here, and a 4 here. And let's take stock of where we are so far. 3 tins, good. 4 nitrogens, good. Now let's make sure everything else looks good here. We've got 4 hydrogens plus 2 hydrogens. That gives me 6. I've got 6 hydrogens, and I've got 4 times 3, I've got 12 oxygens. And I've got 1 oxygen here, so that's going to be 13 oxygens. On this side, I've got 9 plus 4, 13 oxygens. So this is your balanced redox equation. Okay, and these are the half reactions. I hope that helps. If you need any more help, you can just let me know. Okay, thank you.